Mauri oho, mauri tū, mauri ora ki a tātou, haumi e hui e, tāe ki e. Kia ora tātou, nau mai haere mai ki te Māori in Antarctica ka mua ka muri seminar series. So we've had 3 of our seminars so far, and there's a total of 8. And the purpose of this seminar series is to, the idea is in the title, this ka mua ka muri. It's thinking about looking back at our Māori connections to Antarctica and the Southern Ocean, to then define what our aspirations for those connections are in the future, and knowing those aspirations, thinking about what we need to do now. And so this seminar series sets us up for that conversation going into the future. There's all these different avenues for hapu and iwi to engage in this kōrero. And it's really important to sort of set the scene and start triggering those conversations. So hopefully from this seminar series, hapu and iwi can go away and have conversations and engage in the kaupapa more broadly, and identify the avenues in which they want to jump in. I think, so we've had a broad introduction of a few of our presenters so far, and if you did want to engage with exactly who we are, that information's on the website. We didn't want to mihi at the start of every meeting. But enough to say that over time, you'll get to know each and every one of us as we each take our turn in presenting. I should introduce myself. Ko Billy Van Ushek tōku ingoa, no ahi te rari ahau, no ngā rauru, tūhoi me Ngāti Nīralanda ahau. Aye, so I'm your Dutch Māori Aussie cousin, who's sort of come back home to Aotearoa in the last year. And I'll be your facilitator for the seminar series. So we're almost halfway through. And today it's my great pleasure to introduce Dr. Pete Russell. And I guess my only introduction for Pete will be to identify him last year at the MAI conference, Māori and Indigenous conference down in Puketaraki Marae. We dubbed Pete Pono Pete. And that really speaks to his manakitanga that he just exudes. And I know me coming to Otago in particular, he was one of those warm, welcoming embraces that made me feel more at home coming here from Australia. Aye. And to just sort of set the groundwork, this is a kōrero, a two-way street in terms of the conversation. And in a couple of weeks' time, we'll bring hapu and iwi back for a wānanga where it'll really become a two-way street in the conversation. I just wanted to introduce Krishna Watane, who is on screen but muted at the moment. So Krishna is our Māori philosopher, and she brings that philosophical lens to our research team. So we're quite a diverse set of researchers from diverse institutions as well, including iwi representative bodies. So that's, I think, a strength to our kaupapa. So without any further ado, I think we'll just kick over to you, Pete, if you'd like to introduce yourself. And Krishna and I will duck away and come back for question time at the end. So any questions that you've got, nothing's too silly, nothing's off the cards. Please just pop it in the chat or the Q&A channel, and we'll come back to them after Pete's kōrero. Aye, kia ora.
Kia ora, Billy. Tēnā koutou, nei mai haere mai ke tēnei kōrero. Ko Pete Russell, tako ingoa, no Ngāpuhi ahau. Kia ora, I'm Pete Russell. I whakapapata Ngāpuhi. I grew up in Whanganui, and I'm living at the moment in a place called Karatani. So if I share my screen. That's this tropical place here. So I'm going to talk today about Antarctic ice melt and sea level rise, and just to give some basic facts about this topic and where it relates to us as Māori, particularly as, you know, hapu and iwi in the process, or have been in the process of making long-term plans, like, you know, 100-year, 200-year plans, particularly when it comes to the restoration of the motu and the environment. So we were due to go to Antarctica in about a month and a half. COVID-19 put pay to that. So we've been bumped all through to next year. So hopefully next year I'll be heading down to Antarctica. So I really liked the corridor yesterday, and Sandy had a Pacific, a Māori-centric view of Antarctica and where it fits in with the rest of the Pacific. So this is a view of where we are here in Aotearoa. Here's Fiji, here's Hawaii, here's America here, and this is Antarctica here as it was about half an hour ago. You can see most of it's in the dark, and this is our approaching evening in about 3 hours' time. If we take away the night, we can see Antarctica at the moment is surrounded by sea ice. So the continent's actually doubled in size in terms of the ice around it. And this is South America up here, and Scott Base is here. Now, the talk we had before from Dan, he talked about working on the Antarctic Peninsula here. Well, right at the very northern tip of the Antarctic Peninsula last February, they had the warmest ever recorded temperature on the Antarctic mainland continent at a place called Esperanza Base up here. And on that day, they had 18.3 degrees, which is warmer than it's been in Otipoti, Dunedin for the last 2.5 months. Next to the base was Eagle Island, and on Eagle Island, they recorded over that early week in February, melting of the ice sheet. And this is some of the bigger meltings that they've actually recorded. So I don't want to be alarmist in this talk. I just want to put it into context with some of the other climate things that may be happening, and also try and just get some idea of the scale of what we're facing with this ice sheet melting that's going on. So Esperanza Base is there. Here's Scott Base here, and here we are here in Aotearoa. That's a distance of about 4,000 kilometres. And if I was to walk that at a reasonable pace, that would take me about 42.5 days to actually walk that. So just to put that into context. So in relation to Scott Base, here's the South Pole. So the Earth, as people may know, spins around this axis. So that's the South Pole there. Okay, so where does all this ice come from? Well, the weather around Antarctica precipitates onto the continent in the form of mainly snow, and that snow builds up over time into the ice sheet. And this ice sheet is not just solid, otherwise it'd just get bigger and bigger. It's actually moving over time, slowly over time. It wants to move down towards the ocean. In some places where these, what we call glaciers, meet, they form ice shelves. And here's an example of the ice shelf here. They're several hundred meters high, and right near the grounding line, they're actually 600-700 meters deep. So they're quite a sizable chunk of ice. And as we talked about before, during the winter, we get the sea ice freezing. So the sea freezes around the continent, forming the sea ice. And that literally doubles the size of the continent over winter. So at the moment, we're coming up to August, and we're at a point where the sea ice is a maximum. So our water temperatures around Aotearoa at the moment are the coldest at this time over the next month. So contributions to sea level rise. So if we just look at data from the last 24 years, okay, the melting of ice sheets, Greenland has contributed 15%, Antarctic 8%, and other glaciers 21%. So what I mean by other glaciers, they could be things like Fox Glacier, the Tasman Glacier. They're temperate glaciers, and they're starting to disappear. quite quickly, as you may have seen on in the news. The ice shelves, they don't really contribute too much because they're already floating on the water. And the sea ice, that doesn't contribute at all because that's just the sea that's frozen. So these are what do or do not contribute to sea level rise. There's another thing that's missing here, and that's thermal expansion of the ocean. So as the ocean gets slightly warmer, because it's warming up, it thermally expands. And over this period of time, it contributed 42% to sea level rise. Now, if you add these up, you'll see they don't actually add up to 100. So that missing 14% is the uncertainty in our measurement that we're making here. So where is all the ice on Earth? So Antarctica has 91% of it. Greenland, that has another 8%. And the remaining 1% is everywhere else. So they're all the glaciers and ice caps on all your mountain ranges around the world, including Aotearoa. Okay, so the next question people would like to ask is how much will sea level rise if? Okay, if Greenland melted and all that ended up in the sea, roughly about 7.2 meters. If Antarctica melted, 58 meters. And the third question people would like to know is how long have we got? How long will it take? Okay, and these are pictures here of Greenland, and these are rivers that are formed on the ice from meltwater, and then they find their way down cracks into the center of the ice sheet through these holes called molens. So if Greenland lost during this period of time 275 gigatons, which is roughly 305 cubic kilometers per year, and there's that much total ice in Greenland, then surely it's just a simple piece of maths. That divided by that gives us our 10,000 years. Unfortunately, it's not quite that easy, but under current predictions, Greenland will take centuries and centuries to melt. Why is it not easy to predict? Okay, surely it's a simple calculation of quantity of ice divided by the melt rate. Well, that is the equation. The difficult bit is working out the melt rate and then the quantity of ice left at each iteration. So in any one year, if we just take Greenland for an example, we've got to find out how much snow actually accumulates and how much ice actually melts. And that includes how many icebergs carve off from these glaciers as they enter into the sea, and how much water flows down into moulins. And this is now further complicating our equation, because this water flowing down underneath the ice sheet lubricates it and speeds up, particularly the glaciers, their journey through towards the sea. Is all this cool fresh water flowing into the surrounding sea, is that changing the local, regional and global weather patterns, which in turn feeds back into the weather conditions around Greenland? And then there's the final thing. Once the ice starts to go, with no ice, there's no reflection of the sun's energy, so the land and sea absorb a lot more heat, speeding the process up. And the sea itself is particularly good at absorbing the sun's energy. So in a nutshell, climate science is complex due to these many feedback situations that are going on all at once. This is why we need computers to be able to make these future predictions based on our past data, and then we forecast forward what our situation might be in 100 years' time, 1,000 years' time, and so on. Antarctica, how long will it take? It'll take millennia, many millennia. So Antarctica itself, it can be divided into two parts. You've got East Antarctica and West Antarctica. So if we took all the ice off Antarctica, a lot of the continent has areas where the sea is under the ice. However, with the ice there, the sea's not there, but there are places where you have got fresh water underneath the ice sheet. In the past, the West Antarctic ice sheet has melted. We know this from climate records. Looking at glacier cores, they can tell the temperature of the Earth was a lot warmer in periods in the past. So this is one of those warmer periods, which we call interglacial, and that was about 100, this peak's about 125,000 years ago. And these cooler periods are what we know as ice ages. So this last interglacial produced 6 to 9 meters of sea level rise, and that had ocean temperatures that were 2 degrees warmer than today. So underneath West Antarctica, you've got all this area that potentially could be ocean. And just to put it into context how big this area is, here's a map of New Zealand. So one of these areas that is of real interest to scientists at the moment is the Thwaites Glacier System. And this is an area that, apart from the Antarctic Peninsula, is furthest north where there's a lot of main ice sheet. And several glaciers run into this area here. So with the Thwaites Glacier System, warmer water, and when I say warmer water, it could be only 1 or 2 degrees, comes and starts melting underneath the glacier. At the edge of the glacier, icebergs are carving off periodically. One of the big worries about the Thwaites Glacier is where the actual ice sheet grounds onto the continent. Behind that actually flows below sea level. So if this was to warm and break through, okay, potentially that could destabilize the whole glacier and lead to a rapid collapse in glacial terms. The work that we're looking at doing down in Antarctica is on the McMurdo ice shelf. And that's right next to where Scott Base is. So here's Scott Base here, McMurdo Station here, and here's the McMurdo ice shelf and the larger Ross ice shelf to the east here. So with that meltwater that goes underneath the ice shelf, the meltwater that comes back up enters into a supercooled state. And underneath the McMurdo ice shelf, this vents supercooled water. This has been studied by several scientists, and this paper in particular, Robertson et al., is a good publication to get background on that. So with this warmer water melting the water down here, and this could be 700 meters below sea level, as this meltwater rises, because it's fresh, the change in pressure puts it into a supercooled state. And what I mean by a supercooled state is there was a Mythbusters episode and they put a bottle of beer into the freezer, and several hours later they pulled it out and it was still liquid, and then they banged it on the table and it instantly froze. So water, if water's very pure, unless it's got something to nucleate on, it won't necessarily freeze if you drop it below zero. So that's supercooled water. So when they banged the bottle of beer on the table, that produced little bubbles, and that caused nucleation points for the freezing to happen. So as this supercooled water comes up the ice shelf, the change in pressure puts it in that supercooled state, and it starts freezing out on underneath the ice shelf and also under the sea ice as well. Within the supercooled water, tiny little crystals start forming, and they're called fragile ice crystals. And some of these bigger ice formations are called platelet ice. So I'll just show you a video of what it's actually like beneath the ice shelf. Okay, and this is platelet ice you can see here, and occasionally you'll see little sparkles. I fancy that's fragile ice. Okay, that's what it looks like under the ice shelf. So what we're trying to do to actually measure if water is supercooled, we've got to be able to counter for the fact that the water contains these fragile ice crystals. So we need really accurate measurements of temperature and conductivity and pressure to be able to tell if it's a supercooled state. So part of this project is building an instrument that will enable us to do that. Whereby we have two sets of sensors and we have a heating process that will melt those little tiny fragile crystals. So the idea is we build this and this gets deployed on our American colleagues' underwater robot, as they call it. It looks like a torpedo, and that will fit up into this cavity here. And then this is dropped underneath the ice shelf. On a tether by drilling a hole through the ice shelf, and it can travel up to about 3 kilometers. That's how long this tether is, and start making measurements underneath there. So that's what we're hoping to achieve, and we're hoping to be able to make some of the first measurements of fragile ice actually under the ice shelf. Measurements have been made in the past just by drilling holes through the sea ice, and this allows us to get access to some of these locations under here. So the front of the McMurdo ice shelf is roughly 60 meters down. Okay, you don't have to go to Antarctica to see evidence of sea level rise. So this is Ringaringa Beach down in Stewart Island, and this is where the sea level was at the last interglacial, about 9 meters up from the sea level. And this is just at the back of the golf course, so it's a relatively flat surface here, and you can see in particular in this one where the past rocky beach used to be, and that's been tracked up into the strata here. At the back of where I live in Karatani, you can also see evidence of that past sea level. And this is where the sea level was, again, at that last interglacial period. These are nice flat terraces. So this would have all been the seabed. And then when we had the ice age, this would have been a valley that's been carved out. And just in more recent times, each time the river floods, it fills it up with sediment. Okay, so you might see places like this around the country, and that is evidence of past or previous sea levels as well. There are also places where earthquakes have lifted the ground up as well, so it's not to be confused with those. So the sea level today, this is pretty low lying. This is only about 0.5 meter above sea level here. Okay, so it's a little bit lower than that, and each time the river floods, this area here floods, and it was actually past estuary, but they've blocked it off with tidal gates near the causeway. So what can we expect in the next 100 years? Okay, optimistically, an increase of 0.5 metre, and this range here is our error range. Okay, and more pessimistically, getting towards 1 metre of sea level rise predicted from our climate forecasting. So over the last 116 years, the sea has risen between 16 and 21 centimetres. So that's between 2 and 3 credit cards worth of sea level rise. Okay, doesn't seem like much. However, 1/3 of that, or 1 credit card worth, has been in the last 24 years, which is only 1/5 of that time. So we are in a period of accelerating sea level rise at the moment. So what does that mean for here? Okay, that's our most pessimistic forecast, is 0.5 metre. So this potentially would be inundated with water if we didn't have the tidal gates there. However, just to put this into perspective, we've got to think of some of the considerations with sea level rise. So this is a picture here of the day after a fairly big southeasterly swell event at Karatani Beach. This is the Huriawa Peninsula here. And a lot of the sea came in and actually overtopped the road and pushed a lot of this weed down into people's property. It certainly has happened in the past. In fact, talking to one of the kaumātua in the village, she, as a child, remembers before the road was there, when the river used to flood, it used to flow through here, and often the sea would overtop and flow through the other direction as well. So how will your particular coastline cope with extreme weather events, particularly big swell and big tide? This wasn't a particularly big tide. It wasn't a king tide or anything. It was a normal tide, but at high tide, we had this going on. Okay. So, for example, if you're involved in restoration, particularly of estuaries, if you plant trees, will their roots be in salt water in 100 years' time? Okay. Where will stormwater go if sea level is higher? That's another consideration to have. And the other one is, are there other climate change effects, or also just other stresses, for example, like sediment loading, that have a much greater impact now? And one of those could be increasing sea temperatures. So over the last 3 or 4 years, we've had a few marine heatwave events down our coast, and one of them, this weed here is called macrocystis. It's like the rainforest of the sea, and that only grows in waters of about 18 degrees and cooler. So if the sea does get up, some of these kelp forests may disappear. And these are very important nursery habitats for all sorts of fish species. As I said, they're like the rainforest of the sea. During that heat wave as well, we had kingfish come down the coast for the first time. And that has happened over the last 3 or 4 years. So you're seeing new species appear into the ecosystem as well. And that might be a good thing for some people, but it also might have effects as well. So that pretty much concludes my talk. If you have any questions you'd like to ask, I'm quite happy to answer them for you. Kia ora.
I'm coming back. Kia ora, Pete. That's an awesome presentation. And I guess I feel a bit validated in speaking about your manaki that you exude, because every time I had a question, you knew that I had that question. So you read your audience so well, and it really shows in your presentation. So thank you for that. Amazing. People, keep those questions coming in. Please feel free to jump on board the kōrero here. I had a few, Pete, actually, and the question that sort of comes to the top of my mind is something that Troy Basin sort of raised with me when talking about this kaupapa. And his point was, you know, in terms of global climate, there are these cycles that we can see and they're all connected. So do you see if there's any link between the maramataka or Māori knowledge of climate, and particularly in Te Waipunamu, and what we can see in Antarctica? Are there correlations? Because you drew those links between Otapoti and Antarctica quite clearly. Is there a way to look back in the future, back into the maramataka in terms of our maramataka and climate knowledge to start to predict what we might be seeing in Antarctica?
Yeah, certainly. Niwa, Darren King and Apanui Skipper produced a really good set of posters about climate a few years ago, and by talking to kaumātua who know what conditions were like when they were children, a bit like Hinerangi here talking about this, you know, sea intruding through there. They've got that knowledge, and so they're in a position to recognise what is perhaps normal and what's abnormal. And yeah, that's where I see that knowledge being very important.
Yeah, cool. Crystal, you got a question?
Kia ora, Peter. That was really interesting, actually. I was just thinking about my own tribal communities, my own marae communities in Taitokerau. And I was just wondering if you could say a little bit about how important you think it is for particularly low-lying marae, and any marae, in fact, marae communities, to think about sea level rise.
Yeah, a lot depends on how low-lying they are, and because, you know, if you have to move the marae, and you know, that's a resourcing issue. And, you know, like I said, what are there other more urgent things that are happening within those communities? Like, for example, if you've got that much sediment in your rivers and in your estuary that it's killing, you know, shellfish species, and that they might take precedence to sea level rise. But certainly for future planning, it is something to consider. In a century's time, where, you know, in your grandchildren's time, you might have an extra metre. The sea might be 1 metre higher than what it is today. So, you know, if you're thinking about putting a facility somewhere, that might be something to consider long term.
Kia ora. Yes, we've got a question from Martin. So alongside the marae question, what considerations, if any, is applied to this lower lying settlements, and indeed with more extreme weather patterns, how we might look at urban areas and floodwater?
Yes, certainly with extreme weather events, we saw the result of, I think it was Cyclone Fehi and Gita that hit us at the start of last year, or it could have been the year before. So a lot of those low-lying communities were inundated with the sea. That's only going to happen on a more regular basis, because not only with warmer global temperatures are we going to get more tropical storms, because tropical storms is how it dissipates and redistributes that warming around the planet, but also compounding that is higher sea level as well. So yes, certainly in Britain, I know with their sea level rise and their coastal erosion, they're taking a managed retreat approach from the coastline. And that's at local and central government level there. You could fight it, but it could end up being very expensive.
I have another question, if I may. Billy, is that all right?
Of course.
Kia ora Peter again. So I just wanted to press you just a tiny bit on what you might say about how what you've presented, what implications there are, you think, for what we have reason to value and what we have reason to do for the future.
Well, hugely. What we do in our individual lives does make a difference. And if it's just like every tree and every harakeke bush you plant, in terms of restoration, it's twofold. It's helping stabilize maybe vulnerable ground, but also it's reforesting the motu. So, you know, these are things we can do. Also, some of the consumer choices that we make as well. So there's a direct correlation between the amount of carbon in the atmosphere and how warm it is. So, of course, there's a lot of politics surrounding that argument, but scientists are unanimous that carbon, the world's climate is very sensitive to changes in carbon dioxide in the atmosphere. So, you know, reducing your carbon footprint in whatever way you can do that will help. And, you know, people might say, oh, well, you know, this country's still burning this much coal and no, it's not going to make any difference. Well, it's a cumulative effect. And if enough people do it, it will make a difference. Yeah.
Kia ora.
Kia ora. That's Krishel coming with the hard philosophical questions. Thank you, Krishel. We've got a few more coming in. It seems like we've opened the floodgates a little bit. Okay, so Georgia Bell. Kia ora, Georgia. Pete, do you have any predictions on impacts on groundwater?
Yeah, kia ora, e hoa. Yeah, with the Dunedin floods that we had in 2015, so what happened there is South Dunedin flooded and the stormwater system could not cope with the loading and the stormwater goes out to sea. So, and I'm not a hydrologist, so this is probably a question better answered by a hydrologist. But with higher sea level, that stormwater or some of those stormwater systems will have to either be altered or be adjusted to be able to compensate for higher sea level. Yeah. I can remember 20 years ago living in Greymouth, it got that dry that the aquifers dried out and seawater did flow into the aquifer there, and people were having to get their water out of the back of a truck in outside the council building. So, you know, with rising sea level, there is the potential for aquifers, particularly if they're dry, to be inundated. But yeah, sorry, Georgia, you might have to ask a hydrologist that one.
Good answer, mate. Naomi Puketapu-Wait, kia ora, Naomi. Ngā mihi, Pete, love the presentation. Do you see any benefit for having warning systems in around storm surges and extreme weather events, or is it a case of moving things inland to prevent the inevitable?
Yeah, kia ora, Naomi. Yeah, it's quite hard. I know they have a tsunami warning system with civil defence, and I would imagine that might be quite useful locally for storm surges as well. Particularly, you know, I don't know if people remember images on the news of those people in Nelson, and a wave came in and sort of wiped several of them out. You know, to keep people away from the coastline. People, of course, like to go and watch this stuff. It's nature happening. So yeah, certainly the infrastructure's there at the moment with the tsunami warning system to warn people about storm surges. Yeah.
Cool. Thanks, mate. Thanks, Naomi, for the partai. We've got one from Scylla. Scylla's chiming in. How on earth did you get into ice research and physics? How did that happen? It's a good question.
Well, yeah, kia ora, Scylla. That's a good question. I did a physics undergrad degree many years ago now, and I came back and did a master's with the idea of going to work for Fisher and Paykel to make washing machines and the likes. And I became interested in oceanography. And so I did my PhD in oceanography and spent several years working in marine science. And this position that I'm currently in, it's a research fellow position with the Sea Ice Group, funded by the Marsden Fund. They needed someone who had knowledge of oceanographic instruments, but also preferably an electronics background. So it's pretty much at the business end, an engineering related project. So that's how I've ended up in sea ice research. Yeah.
And you haven't looked back since, eh? And here you are on a seminar series. Kevin Norton's chimed in. Kia ora, Kevin, from just a few doors down from me. It was good to hear you talk about the knock-on effects of sea level rise. As a geomorphologist, I'd encourage us all to think about the links between climate and processes on the land, storminess, flooding, landslides, soil. You did a great job of highlighting the Earth as a connected system. So it's more of a comment. Did you want to sort of build on that in terms of how do you see hapu and iwi sort of engaging in this kōrero as it sort of progresses? It seems like it's really topical. I know that there's lots of people talking about it right now. Do you have any sort of indication of where the conversation is at with hapu and iwi?
I think what's really important, particularly if you're looking at the ecosystem level, is looking at these ecosystems at the moment are suffering from multiple stresses. So you've got a combination of several things happening at once. So if they had to just take on one of them, the ecosystem might come out reasonably intact. But when you've got overfishing, warming sea temperatures, climate change, ocean acidification, sediment seems to be a big one in a lot of these, multiple stressor systems, sediment loading, then this pushes those ecosystems to tipping points where they collapse and decline. Particularly what I was talking about, the macrocystis here on the screen. South of Dunedin, there are reefs that used to have macrocystis, and they disappeared sometime in the last century. And was it one particular flood event, for example, where the sediment loading was that high that ended up pushing it over the edge? So this stuff at the moment on our coast grows down to about 10 metres because that's all the visitors. But you go down to Stewart Island and places like that, it grows down to 30, 40 metres. So, that means bigger kelp forests, which means more fish and, a healthier ecosystem. So, yes, certainly having the conversation about what stresses there are and what mitigation can have and what are the really important or the really high impact stresses. And certainly in some of the literature out there, sediment loading or sediment has been identified as a real big one. And that requires a catchment-wide cooperation and a catchment-wide type change to reduce that sediment loading, and changes in forestry practice and changes in agricultural practice, those types of things, which are more terrestrial-based type fields, but certainly the impact is seen in the marine space, yeah.
Kia ora, Peter. I have another question from Scylla. So you talked about measuring under Thwaites Glacier and in McMurdo Sound, but are there any other places in Antarctica where it's important to measure what's going on?
Okay, so I can only speak about the work that I've been doing and our American colleagues have been doing, but certainly they're looking at right deep in the Ross Ice Shelf, right near the grounding line as well, called the Cam Ice Stream. That's another area that both our American colleagues and Effort and Aotearoa have been looking at as well. That's where the Ross Ice Shelf is grounding. In terms of just this melting type research, yeah, the Thwaites Glacier system is called basically ground zero for climate change. They call it the Doomsday Glacier. So it's like the canary in the coal mine as far as melting goes. But yeah, certainly that is another site that I know of as well.
Cool. Well, Scylla's coming back with more questions, dominating the chat. She's asked just what's the grounding line exactly? Okay,
so when we've got an ice shelf, okay, a lot of it is out just floating over the sea. Okay, the grounding line is where it hits the bottom of the sea. So this is like the grounding line here. Okay, where it's, you know, hard up against the solid earth.
Cool, thanks, mate. And I think we might be up to our last question. But I just wanted to ask, to bring it back to your research, do you have any, I guess, hunches on the scale of which we'll see the sea level rise? So you gave like a range, a fairly broad range of this is the best case scenario, this is the worst case scenario. Yeah. Do you have any sort of idea based on your understanding of the mechanics and what you expect to sort of come out of your research on where we'll sit on that scale?
So yeah, I'm certainly not an expert in this area. We have had a computer modeler who has just left to go back overseas that works on this. So what we're trying to do is we're trying to just find out about one piece of the jigsaw puzzle, and then that, once we've established that will fit into the larger climate models. So if I was to have a hunch, certainly I would tend to the more pessimistic outlooks, particularly because we've just in the last sort of decade gone through an accelerated period of, you know, heat. Records are falling all over the place in terms of highest temperature in Antarctica, the marine heat wave that we've had here. Yeah, so my outlook would be a lot more pessimistic. But certainly it's got to be put into context. You know, you can't say, you know, it's going to be 7 meters by the end of the century. So we've got to shift our whare next week, sort of thing. Yeah.
Awesome. And I guess just to sort of end it there, we've gone a little bit over time, but that seems to be our way of doing things. I blame Crishel, talking too much. So might just have time for one last question or one last comment from yourself, Pete. Crishel, did you have any other hardcore philosophical questions to bring on for Pete?
Not from me, but I thought that was really fascinating. Thank you, Pete. Lots of things to think about. Kia ora.
Did you have any last words, Pete, that you wanted to kōrero?
Yeah, probably, you know, the most important thing, someone asked a question about, you know, storm surges and that. I think, you know, sea level rise has got to be taken in with the other stresses and included in with those other stresses. Like I said, a warming climate, we're going to have more storms. So what might have been a 1 in 200 storm event up in Te Tai Takara the other week might be 1 in every 10 years. And that's got to be taken into account in conjunction with sea level rise and some of these other stresses. Yeah. So Yeah, kia ora, Billy, for organising this. It's a real privilege to come and talk today. And thank you, Scylla, as well for your work, and Crucial for tautoking my talk here. So yeah, kia ora.
Kia ora, Pete. Thank you very much. And I just want to point out again that you always live up to the name of Puno Pete. The manaaki that you show through your presentations and in everything you do is awesome. I'm really glad that we've gone over time and drawn out that conversation, because I know that Hapu and Iwi will be really keen to get involved in this sort of research. It seems to be something that's certainly on the cards for people on coastline. I guess we'll just finish it there, and thanking Pete. For all of our audience, I just want to make sure that you're aware we've got 4 more seminars to go. So 2 more tomorrow, and you'll receive invites to each of those. The purpose of these seminars is for Hapu and Iwi to really engage with it. If your questions weren't answered during the presentation, or you weren't able to make it, please make sure that you do jump on online. All of these will be recorded and embedded online for you to engage with when it suits you, and to ask those questions. And then in a couple of weeks, we'll have an online wānanga that brings Hapu and Iwi into the conversation more. They'll be far more well informed and a better idea of where their inroads into this kaupapa might be. Scylla, did you have any words that you wanted to share?
No, just yeah, awesome, Pete. Yeah, he mihi nui kia koe. Yeah, love your work, and I think fantastic to see Māori in there thinking about problems that have real relevance for Māori. So yeah, he mihi nui kia koe, Pete.
Kia ora. I might just finish off with karakia then, hey, if that's all right, and bid everyone adieu, and we'll see you tomorrow. Unihia, unihia, unihia ki te uru tapanui, kia wātea, kia mama, te ngākau, te tinana, te wairoa i te ara takata. Koe aroa, rā e rongo, whakairia ake ki runga. Kia tīna, tīna, huie, tai.
Oh, yeah.